PowerShell is a legitimate Windows utility for task automation based on the .NET framework. It has broad access to system features, and it's installed by default on all popular versions of Windows, starting from Windows 7. Attackers prefer PowerShell for lateral movement scenarios because it can be executed remotely on other machines. Another reason is that malicious scripts can be obfuscated and supplied within the command line to hinder analysis during an investigation. Because we're not able to detect any actionable artifacts on disk, we rely on a different detection strategy. We need to capture the contents of the malicious script before execution to properly analyze and establish the impact. This capability is called script block logging, and it's available on the newer versions of PowerShell. It records the commands that get executed in line, as well as captures the entire modules that are loaded into memory. And this will capture everything. It's available from version 5.0 onwards, so we can configure this directly on Windows 10, but for older Windows 7 operating systems, this requires an update for PowerShell. To enable script block logging requires a configuration via policies. Now that we know where to get the required information, it's time to learn what exactly to look for. And there are some key indicators to look out for based on the log data collected. The first category are suspicious parameters. A good example here is a bypass in the execution policy, although some admins might be guilty of using this as well. Passing a large payload to a PowerShell command will create very lengthy commands, which can be used as an indicator. Attackers will encode their commands in order to avoid detection by searching for common function names in the logs, but you can use this as an indicator as well. Depending on your PowerShell scripting skills, you might be familiar with this. If not, we'll consider a few examples to get you more familiar with PowerShell-based attacks. This is a great example of a suspicious PowerShell command, especially when we look at the parameters. -exec is short for execution policy, and in this script it's configured to bypass, meaning the script can be executed and it will not be blocked. The second parameter will specify that the window will be hidden, meaning the user will not see a PowerShell prompt and it will run in the background. -enc is short for encoded command. This is used for supplying the large base64 string containing the encoded commands. Now let's look at another example. This command will first invoke an expression. A new web client object is instantiated to download a payload. The malicious script in this case will be a PowerShell implementation of Mimikatz, which is a tool for credential dumping. After being downloaded, it will be executed. In this final example, two commands are executed. The first one will set a registry value that will enable for clear text credentials to be stored in memory. If we take into consideration the previous code snippet, we can establish that the attacker will attempt to steal credentials. The second command is similar to the previous, that is used to download the module as well as pass the IP address of the attacker as a parameter. More advanced attackers caught up with the increasing trend of monitoring script logs, and they want to avoid detection when leveraging PowerShell for post-exploitation. For this reason, they might use PowerShell version 2 for attacks. This will provide them with similar functionality. It's installed by default alongside version 5, and it does not support script logging. Here's a better way of showcasing this concept. The attack can start using PowerShell version 5, for which we have the logging capability. Then it can call another PowerShell process that is actually version 2. For this, there is no support for logging of commands and payloads. After which, the attacker can execute malicious payloads without us having visibility, unless we leverage other detection capabilities as well. The goal of this demo is to identify post-exploitation attacks based on PowerShell. And to achieve this, we'll leverage the logs captured by WinLogBit in the Elastic Stack. Since the PowerShell script logs are captured in the Windows event logs, we rely on the WinLogBit index data for our investigation. And we'll first start off by setting a filter for the specific PowerShell category. Next, we'll search for event code 4104 as this corresponds to the scripts being logged. And we're now looking for the field that captured the script block text. We'll add this field as a column in our search. And now everything becomes more clear. Based on this information, we can see that a very long PowerShell command has been executed. We also notice that the logging module, while executing the script, has extracted and decoded the value of the encoded string. Even more interesting, we can see that for a rogue PowerShell script that was loaded into memory, the entire contents of the script were captured. We also have to consider that turning this capability on will generate a lot of log files. We can also see that the logs stop after a PowerShell prompt is created for calling PowerShell version 2, which does not support script block logging.